How did it feel?
It felt great. It did everything we expected it to. Felt real good, real stable, and ought to be a whale of a good airplane.
Did everything work as promised, and you felt it would? Any problems?
Yeah,
anything worked better?
Everything worked just like we expected it to, and the things we looked at on in simulation, as well as out here on ground run and through the progressive steps of system evaluation, looked real good. We're real proud of it.
Okay, so where do you go from here? What's the next step for you on this?
All just to increasing speed incrementally, in a prudent way, of course. But based on what we've seen here today, I think we'd expect it to be everything we hope it to be.
Okay, great, thanks. Sir, how did you feel about it?
Well, I think we started a new era in aviation, and I think the tilt rotor is going to really make a big difference in VTOL type of aviation. I think it was better than we expected, and things went very well. Everything works very well. It's a terrific aircraft.
Yeah, that thing lifted off for the first time, thinking about it. What were they?
Another first for the Marine Corps, and a great thing for Bell and Boeing.
From Bell's standpoint, what do you see as the future now, Bell and Boeing for the V-22?
Thousands and thousands of tilt rotors. That's what I see. It'll be the beginning of a new era in the vertical takeoff and landing world, without any question. Great day.
All right,
fantastic.
Incredible event.
Well, it's so exciting to me to see the team, and you couldn't tell who was Bell and who was Boeing, and you couldn't tell from the pilots down. It's just a big team effort, and Jack and I are ready to move on with the program. This is a great milestone.
Describe the use that the Marine Corps will have for the V-22. How do you plan to see it for the Corps?
Okay, well, of course, we'll be using it to extend our range, our speed, and our capability of moving our forces about the battlefield. And it gives us a lot longer range, much more survivability and speed, agility, over-the-horizon capability. So we're very excited about getting this into the forces as soon as possible.
Okay, thank you, General. Appreciate it. Thank you, sir. Okay. David, get a shot of these guys here.
Damn right it was.
What a hell of a day.
Yes, sir.
Great. Dick, nice.
Thanks, Alice. Appreciate it.
You got a second?
Sikorsky aircraft Shadow demonstrator, with its test station up front, provides a flexible flight laboratory for validating advanced pilotage systems for LHX. Boeing Helicopters modified this A-109 helicopter for the ARTI program. The aircraft had a unique buried cockpit in the passenger compartment, permitting the test pilot to assess nap of Earth flight without a direct view of the outside world. The extensive simulation capability of both companies was brought into play in ARTI and continues in the LHX program. To duplicate nap of Earth flight conditions and vehicle capabilities required, moving base simulators are used in engineering development at both locations. The computer-generated displays are the most advanced available and are continually being upgraded. Our LHX design has a highly automated flight control system using fiber optic cables for lower weight and assured survivability against electromagnetic pulse weapons and conditions. This technology has been proven in over 6,000 hours of ground and flight testing in ADOX, the U.S. Army and Boeing Helicopters' Advanced Digital Optical Control System program. Our team has experience with arming helicopters with a wide variety of weapon types. The original S-67 Black Hawk, an armed helicopter built on an S-61 drive system, was a pioneer development in heavy attack helicopters. Armament systems for the current UH-60 Black Hawk helicopter included Hellfire missile firings and are now deployed. An armed version of the AH-76 Eagle has been demonstrated with typical modern armament packages. For the DEMVAL program, the primary effort is to design the Mission Equipment Package, the MEP. We will provide the LHX with the ability to see first and shoot first. The sensors, signature and data processors, data paths, displays, and armament systems all have to be integrated into a coherent, robust, and efficient fighting machine. Boeing Military Airplanes is the avionics systems integrator for the Boeing Sikorsky LHX First Team. They will make sure that all of the MEP components work, individually and as a total system. Their ability to handle this critical and complex task, encompassing both hardware and software, was developed and refined on systems like the B-52 avionics upgrade, the B-1 offensive avionics system, and ATF avionics integration. Prior to flight checkout, the LHX MEP will be thoroughly verified in a systems laboratory at the facilities of Boeing Military Airplanes. Individual subsystems will be provided by first team members. Boeing Military Airplanes is currently developing the avionics communication system for the new Air Force One, the personal aircraft of the President of the United States. This is one of the most complex and survivable airborne communication systems ever assembled. The heart of the LHX mission equipment package is the target acquisition system and the pilot's night vision system. These advanced sensor packages will be provided by Martin Marietta, who are developers of the current generation systems in the AH-64 Apache. Targets are identified and categorized by an aided target recognition system being developed by Westinghouse. Martin Marietta and Westinghouse are jointly developing the Airborne Adverse Weather Weapons System, OZ, for the Apache. A lightweight version will be supplied for LHX. A wide field of view helmet-mounted display using advanced optics and electronics allows the pilot to simultaneously view targeting and pilotage sensor data. No reference to the instrument panel is necessary. Both Hamilton Standard and Kaiser Electronics are developing alternative designs of this display. The best features of both will be incorporated into the final configuration. Kaiser Electronics' background includes an Army infantry helmet display and the Agile Eye helmet. Hamilton Standard and Boeing Electronics are working cooperatively to develop an all-digital, fail-safe flight control computer. The control laws incorporated will provide outstanding flying qualities and a low workload for the pilot. Harris is providing the flat panel multifunction displays in the cockpit. Expert system software will prioritize information to be displayed. The pilot can concentrate on essential tasks, but retain flexible access to all aircraft and weapon system data. A three-dimensional digital map provides the pilot with a view of the terrain from a choice of perspectives. Zero visibility navigation and pilotage is possible in a low signature mode. The Harris digital map is based on extensive operational experience with the F-16 fighter installation. TRW and Collins are prime contractors for the Tri-Service Integrated Communications, Navigation, and Identification Avionics, ICNIA. The LHX version will reduce power and weight and allow more accurate target handoff. Centralized signal and data processing based on PAVE pillar architecture and VISIC technology will support all sensor subsystems. Pooled spare processors and self-reconfiguration will provide ultra-reliable operation of mission equipment processing. A 100% reserve processing capability will be provided in the initial design. Westinghouse, supported by TRW and AT&T, is developing this system using a military standard instruction set and software written in the ADA language. Super high-speed data buses are the key to integrating the operation of the many sensors and the central processor of the LHX MEP architecture. The result is faster target acquisition and the ability to get off the first shot. Harris is an industry innovator in fiber optic data bus systems. An integrated diagnostic prognostic system will accurately and simply pinpoint active and potential faults, allowing immediate corrective action and aiding long-term maintenance planning. Unnecessary component removals will be significantly reduced. The Hellfire air-to-ground missiles and the Stinger air-to-air missiles are carried in retractable racks to reduce drag and meet low radar signature requirements. Martin Marietta is a supplier of the Hellfire system to the U.S. Army. The turreted, multi-barrel 20mm cannon is slaved to the pilot's line of sight. Pointing information appears on his helmet-mounted display. A high-fidelity fire control system combined with dynamic bore sight correction assures hitting targets using only short bursts. General Electric has a vast background in cannon systems and provides them to the U.S. Army for the current fleet. A critical element of the LHX program will be a complete training package, including embedded training features, part task trainers, and highly realistic combat mission simulators. Link Flight Simulations, the industry's simulation leader, will be an integral part of the engineering development team. This will assure that the first team has a fully developed operator training device system available for training crews, well before production deliveries start. The first team is motivated by the total quality concept. Concurrent engineering teams employ man-print principles from initial design, assuring a user-oriented LHX. Manufacturing engineering input is aimed at meeting the not-to-exceed $7.5 million target price. The first team for LHX, first in commitment, first in capability, ready and able to meet the Army's combat requirements on time and within budget.